All right, welcome to the Explainer. Today, we're diving into something that could completely flip the script on our mobile networks. We're talking about transforming them from dumb machines that we have to program into intelligent systems that we can just talk to. So let's get right into how this crazy idea actually works. I mean, just think about it for a second. What if you could just tell your network, hey, prioritize video calls for emergency services right now? And the network gets it. It just understands you and reconfigures itself in real time. No programmer hunched over a keyboard needed. This isn't some far-off sci-fi dream. It's the core idea behind a brand new framework called AgentRAN.
So here's our game plan. First, we're going to look at why our current networks are frankly hitting a wall. Then we'll introduce the solution, AgentRAN, which is all about giving the network a brain. We'll peek inside that brain to see how these AI agents think, then watch it get put through a high-stakes emergency test. After that, we'll uncover how it can actually learn and get better all on its own. And finally, we'll tackle the big question. Can we really trust an AI that thinks for itself?
Okay, so before we can really appreciate how revolutionary this is, we first have to understand the problem it's trying to solve. Look, our current mobile networks are absolute marvels of engineering, but in a world that needs to change on a dime, they're starting to feel a little old-fashioned. Think of today's networks kind of like a train on a fixed track. They're incredibly powerful, but they are rigid. Every single change, every tweak requires a human to go in and manually write new, complicated code. The future, though, is totally different. It's dynamic, it's adaptive, it uses what's called intent-based reasoning, which is just a fancy way of saying it understands your goals when you state them in plain English, just like how I'm talking to you right now.
And that right there is where AgentRAN comes in. This isn't just another upgrade. It is a complete reimagining of how a network is controlled. It's about moving from a system of hard-coded rules to one that can actually reason and act on its own.
At its core, the secret sauce in AgentRAN is the same kind of AI that powers stuff like ChatGPT, large language models. It uses them to create a whole team of AI agents. Now, these agents don't need code. They get natural language. A human operator can give them a high-level goal or an intent, and the agents just figure out how to make it happen. Now, you're going to hear the term RAN a lot. It's super simple. It just stands for Radio Access Network. You can basically think of it as all the gear, the cell towers, the antennas, that connects your phone to the rest of the internet. And AgentRAN is designed to be the new brain for this incredibly critical piece of our infrastructure. So how in the world does this actually work, right? How can a piece of software manage something as insanely complex as a mobile network? Well, it turns out the whole system is designed to act a lot like a really well-run company. Okay, picture this. The human operator, that's the CEO. They set the big picture vision, like maximize performance for everyone. Then you have a manager agent, who's like a director. They take that big goal and break it down into concrete strategies. And then you have the specialist agents. These are the real experts in things like power control or data scheduling, and they're the ones on the ground actually executing the plan. This whole process has a cool name, the intent cascade. It all kicks off with a simple English command from a human. A manager agent grabs it and starts breaking that big goal down into smaller, more technical tasks for its specialist agents. Those specialists then give direct commands to the software controllers, called dApps, which are the things that actually adjust the network hardware in real time. And get this, they literally talk to each other to solve problems. So the manager might say, hey, we need less lag on the network. The uplink agent, which handles all your data uploads, might report back, uh-oh, there's too much traffic, things are getting congested. The manager then negotiates a solution, telling one agent to prioritize critical data while telling another one to boost the signal power to make sure the message gets through. It's like a constant, high-speed digital conversation to keep the whole network running perfectly. This all sounds fantastic in theory, right? But the real question is, does it actually work in the real world over the air? Well, the researchers put AgentRAN to the ultimate test in a live 5G network with a really high-stakes emergencies scenario. The experiment was broken down into 3 phases. First, a stretch of just normal, everyday operations. Then, suddenly, an emergency is declared, and all the priorities get thrown out the window. And finally, a post-emergency phase where they get a whole new set of goals. Let's see how these AI agents handle the pressure. So, in phase 1, the goal was simple, just maximize performance for everyone. The agents balanced all the resources fairly between 2 different groups, regular home internet users, or what's known as fixed wireless access, and a set of security cameras, which are a type of machine-type communication device. Both groups got a nice, stable 20 megabits per second. So that's our baseline. Then the emergency hits. A new command comes flying in. Prioritize the security cameras. They need at least 30 megabits per second, and they need it now. And instantly, the agents spring into action. The scheduler agent immediately throttles the home internet user's speed, while the power agent cranks up the transmission power for the cameras, basically boosting their signal to make absolutely sure that critical video feed gets through, clear and reliable. And the result? It worked. It worked perfectly. The critical security cameras immediately saw their speeds jump up to between 30 and 40 megabits per second, exactly what the operator asked for. No human had to write a single line of code or flip a physical switch. The goal was just stated in English, and the AI network reconfigured itself in a matter of seconds to make it happen. Okay, now for the final phase. The emergency is over, and the AI gets a new, much more complex goal. Go back to prioritizing the home users, but now make the camera save as much battery as possible. So the agents had to understand this tricky trade-off between performance for one group and efficiency for another. And they did. They immediately lowered the power for the cameras while giving all the bandwidth right back to the regular users. And the result here was just incredible. The agent's new strategies saved the camera devices around 200 milliwatts of power. Now, that might not sound like a lot for just one device, but imagine scaling that across thousands or millions of devices on a network. It represents a massive, massive savings in energy. This proves the system isn't just reacting, it can optimize for multiple, even competing goals all at the same time. But this is where the concept truly rockets into the future. AgentRAN isn't just designed to be smart, it's designed to get smarter, all by itself, over time. And this is done through a component they call the AI-RAN factory. The AI-RAN factory is basically like a built-in R&D department for the entire network. It is constantly watching how the agents are doing. It analyzes their decisions, it listens to their conversations, and it looks at the network outcomes. And when it finds a weakness or just a chance to do something a little bit better, it automatically creates a new, upgraded agent and deploys it into the system. This creates this incredible, continuous self-learning loop. The factory observes, it identifies a flaw, maybe an agent is using a little too much power during off-peak hours, then it generates a more efficient version of that agent using all the latest AI tricks, and then it deploys it. The network literally evolves its own intelligence. So what we're seeing here with AgentRAN is a massive paradigm shift. We're moving from networks we program to networks we just converse with, from static systems to ones that adapt, learn, and evolve on the fly, which of course brings us to a final and pretty critical question. As the researchers themselves put it, this technology fundamentally redefines how our networks are going to operate in the future. I mean, the ability to interpret, adapt, and optimize completely on its own is a leap forward that promises just incredible efficiency and responsiveness. But it also leaves us with this final thought. As we build out our most critical infrastructure, our communication networks, our power grids, to be intelligent enough to understand our intent and even improve themselves without our help, how do we make absolutely sure that we, humans, always remain in control? That's the question we're all going to have to answer as we start building the networks of tomorrow.